Well, we're riding around in our 2004 Mustang, man. The thing drives great, even runs great. Problem, when I go to stop, I start slowing down and stopping, man, it's got a pulsation second to none. I mean, it's chattering my teeth. That's not a good thing. So we're gonna have to diagnose it and fix it. So today on Tech Garage, join us for this Pony Pulsation Elimination episode. Welcome to Tech Garage, presented by rockauto.com. Well, we got our resident Mustang here in the shop, and Brian, I have to ask you, man, are my teeth all right?
You know, I'm not sure why you're asking.
Well, I'll tell you what, I paid good money for them first off, but when I hit the brakes, man, this thing is chattering like crazy. I mean, I thought I was actually chipping my teeth. It was bad.
Wow. You have any other symptoms? Drivability, you hit the brakes, pulling left, pulling right, anything else?
Great question to ask. Matter of fact, it's pulling to the right a little bit as I'm driving along. Doesn't feel like an alignment, kind of feels like a suspension issue or something, but really, when I stop, it wants to snatch it to the right and then straighten up.
Well, there you go. I mean, that takes a substantial effort. This is a rear-wheel drive car, and that thing should spin much more freely than that. We got something hung up, could be a caliper, sticking piston. We got a little investigation to do.
Well, you're the brake expert, so you know you might as well go ahead and do the full-blown inspection while you do that. I'm suspecting that thing got hot and caused some pulsation. I'll set up a demo, man. You get to work.
All right. Well, it certainly wasn't from him driving fast. I think we've established that. All right. I've got 3 of the lug nuts off here. Let me get these other 2 so we can get a good look and see what's going on in here. All right. Come down with our wheel. Down here in the bottom. All right. So typical good visual inspection. You know you're looking for any kind of leaks back here on the brake line. Nothing dripping, no evidence, no tracks there. Again, this guy is really hard to spin. So this caliper, a pad either inboard or outboard here is sticking. So what I'm gonna do is take this caliper mounting bracket off. It's a 15 millimeter on the back on this Mustang. Let me first see if I can work this loose and relieve that pressure. That's essentially overcoming that back piston to get that thing a little bit of relief, and that's spinning a little bit better. So I'm gonna go ahead and get the caliper off here. Probably end up replacing this. You have some choices. You may want to rebuild it. We'll get in there, see what's going on, and in the meantime, John's going to tell you how this whole brake system works.
Well, we've been talking about pedal pulsation. Well, how does it happen and what causes it? Well, actually, look at this graphic right here. Pedal pulsation is showing you where the rotor is going back and forth like this here, and it's hitting the rotor. Well, that really doesn't cause pedal pulsation. I'll show you why in a minute. But first of all, we have to make sure we eliminate that. And we're doing it with a dial indicator. We're measuring it. Well, check this out. I got it set up over to the rotor, and I'm at 0. If I slowly turn this rotor around, wow, we're up to 10, 15 thousandths, and then I come back around to 0. That's 15 thousandths of run out. That's a ton of run out. But what really happens is that creates disc thickness variation. I'll show you how to measure that, or a term called parallelism. You come here and you measure the rotor in 8 different places. Now you don't want any more than about a 1/2 thousandth of an inch, not much, of in and out of disc thickness variation. Well, why is that? Watch this. Let me tell you. 3 thousandths run out will go around in 1 mile. It'll hit that rotor 836 times. It'll hit that pad. So as it's hitting that pad, think about that. 6,000 miles, 5 million times you're hitting that. So what's happening when you continue to hit that spot there, it's going to wear an indentation in on that rotor. That's when you get that pedal pulsation happening. You're feeling that in the pedal. That needs to be addressed. Now, how do you address it, or actually, how do you prevent it? That's what we're all about. Well, you can see here our caliper. Our caliper has a square cut seal. That's the only thing pulling that caliper in and out. So the pads contact the rotors, that guy has to work, so make sure it's lubed up. Now another thing you want to do is clean your rotor. Make sure you got a good maintenance surface, inside and out, and put your wheels on with torque sticks or a torque wrench. Don't create your own pedal pulsation, Brian.
I tell you what, I hear you. It's certainly not from the way you're driving. Hey, on my dial indicator over there at the car, I first made sure our wheel bearing is good. It's true, so we're not out of oscillation from that. And I only had 3 thousandths of lateral run out on the rotor surface. resurface. So I think you actually caught the problem early.
Perfect, yeah.
Yeah.
Well, that machine will do a great job, but we're not gonna end there. Go ahead and take your rotor, your caliper, you want this rotor?
Yeah, that looks like the hat you wore to that last event we went to.
Absolutely. Well, Brian, we're almost ready to eliminate our pedal pulsation. Stick around, we're gonna hit the Hunter Auto Comp Elite right after this break. There's plenty more Tech Garage presented by rockauto.com.
Tech Garage, presented by RockAuto.com, is brought to you by AP Laser, leading the way. Custom Auto Sound, the originator of classic car OEM fit radio since 1977. And by RockAuto.com, all the parts your car will ever need.
Welcome back to Tech Garage, presented by rockauto.com. Well, we're ready to get rid of our pony pulsation, Brian.
Absolutely, and tell you what, before we do anything with resurfacing your rotors, we got to first check and see how much thickness we've got. So we got the mic here. Let's just come in and take a good reading. We get down over here, set my drag. Are we good? Yep. We got 1.06 inches of thickness, John, and spec says we could go down to 0.97. So we got plenty of rotor here to work with.
Yeah, and you know what? We're going to make easy work of this with the Hunter Auto Comp Elite on the car brake lathe, man. This thing couldn't be any easier. This is so cool. Matter of just wheeling it over to the car, 110 plug, bam, we plugged it in. Guess what? Brought it up to the wheel, put the adapter on. How do I know what adapter to put on? Tells you right on the screen, simple as can be. Torqued it down, went here, attached the machine. We're actually ready to compensate this thing. Now, cool part, Brian, Auto Comp Elite. It's gonna do it all by itself, man.
Here we go. Let's see, we tell it okay. Here we go.
Speed it up a little bit. Let's get it to about 80 RPM. Yeah, that's 80's nice right there.
84 is good.
All of a sudden, bam, look at that. Starts compensating, we're waiting, and bam, that quick.
Wow.
It just took that wheel hub, everything into consideration so it can cut, and it can cut right. Now, hey, I love cutting brake rotors, nothing like before, so.
Absolutely, I'll tell you what, we didn't have to take it off the vehicle and take it over to the lathe like the old days, and there's certain times you would want to do this, other times you would want to replace the rotor.
Yep, well let's go ahead and set it up, just like you would do a regular brake rotor. So what I'm gonna do is I'm gonna open up the back one, I'm gonna take a scratch cut in the middle. I always like to do that. Hey, however you wanna do it, that's fine, but I take a scratch cut just to know the distance. So I'm bringing it in and I'm listening. I'm listening and I'm listening. Bam, I hit it. Good time to lock it. So I can go ahead and lock it, come over here, do the other side. Unlock it, come in for my scratch cut. I'm coming in. Oh, I hit it. You can see it scratch.
See it.
Cool part is you hear the because that's that pedal pulsation.
That's the pulsation you were talking about.
Now what I'll do is I'll run it in, and it's nice, man. So smooth operation. I'm coming in, get on that inside lip right there. Wonderful. Now I can come back out. I can open it again, open the bit, and I'll take about a 4,000 bite out there.
There you go.
I know what you guys are thinking. 4,000 bite? No, that's too much. Hey, this thing's got round bits, anti-chatter technology. We can do it. So we're going to take this one out here, take a 4,000ths on that guy, bite, hit it. All I have to do now is lock it in. And you know what we're doing, Brian?
We're cutting.
We're cutting a rotor. It's that easy.
Let's let this thing get to work. Now let's talk about why. Let's talk about use cases here. You know what? A lot of hub assemblies on today's vehicles are really complex and laborious to get off and either take to a lathe and get returned or simply just to replace them, even though a lot of rotors are still affordable. But this takes all of that out of the equation. If you're taking your vehicle to a mechanic, have this conversation and determine, are you going to resurface my rotors or are you going to replace my rotors? Now, one thing to remember, at the beginning of this, he had a pedal pulsation. I checked that rotor when I pulled the wheel off. Sometimes you've seen a deep groove cut somewhere in your rotor, too deep to even resurface. We did not have that, which makes this one a really good candidate for the resurfacing job. If it had a big cut, big groove, we wouldn't be doing this. We'd simply replace it with a rockauto.com rotor.
Now, a couple things. Why on my end as a professional technician? Well, man, guess what? Time's money, man. Every 6/10 I get paid, so I don't get paid sitting around. So number one, I hooked it up in no time. Number two, I'm cutting the hub, the rotor, the car. If I took this off and I went over to a rotor, Brian, or a machine, I'm at the mercy of the machine and that. I'm not just cutting the rotor, I'm auto-comping the Hunter all the way through the whole vehicle. So I'm making sure the hub, the rotor, and the bearings are all cut precisely. That's cool. Also, you hear the motor speeding up and down? Whoop, whoop, whoop. First of all, it's one of the biggest horsepower motors in the industry, so we can cut big old trucks. But here's the deal. It's pulsing like that. It's got anti-chatter technology. It's actually sensing that. So you don't get those record grooves like you normally would.
Yeah.
So the pads aren't going to go up. And you got the round bits, so you can take the big bites.
Yeah.
So you're not going to get any chatter. You see any bands on here?
No, it looks fantastic.
That's the deal, man. I mean, think about the coefficient of friction. I'm listening. This thing's cutting. Time is money. Bam, bam, bam.
I wouldn't even have this set up on the lathe over there yet.
Nope.
There
Guess
goes
what?
the edge. There's no edge.
You hear it?
Perfect. Slowing down.
Voila. Hit
Just
stop.
that easy.
Yep.
Just
Looking
that
good.
easy.
Hit stop right there.
Impressive.
Look at that joker.
That looks awesome. That looks awesome. Well, I'll tell you what, there are certain use cases. It's incredible the amount of technology that's out there and available today. Again, you probably don't have this at home, but have a conversation with your mechanic if you're going through this and decide what's best for you. But this is amazing technology.
Yeah, man, I look forward to getting to the LS project. LS lesson, stick around. We're down to the meat and potatoes, man. We're going to pop the pistons out of that bad boy. We'll be right back with more Tech Garage presented by rockauto.com.
Welcome back to Tech Garage, presented to you by rockauto.com. Folks, it's the final stage of disassembly of our LS lesson engine. I can't wait to get this beast back together, but a couple more stages to go.
Yeah, we actually took the pistons out here and we got some of the main caps off and ready to go just to make it speedier, but we left one in just to show you how. Before we took the piston out, the first thing we had to do is take this ridge ream off. Well, what's a ridge ream? Well, the piston goes down in here and it creates this big lip right here. So we don't want to knock the piston out because that'll definitely break the piston. So rockauto.com, I got this ridge reamer tool, pretty simple, fits in there. What you do is tighten it up till it's a little snug in the cylinder. When it's a little bit snug, now I'm going to come back here and I'm simply going around, and when I'm going around, I'm actually cutting the cylinder. So I'm cutting, tightening, cutting, tightening, cutting, tightening. So eventually when I pull it out of here, you'll see, you can actually hear it. Whoa.
It's working. And a couple of these cylinders had more of a shelf and a ridge than others.
Right.
So it really does make a difference.
Yep. Take it out of there. And you can see it's been cut there, so that's good news.
Perfect.
Now the piston's able to come out. So, Brian, time to put a little muscle in
You're
it.
going to come down around your way right here.
There you go. Beautiful.
You got one main cap bolting just for safety. You don't want that crank falling out on your toes. That's going to be a bad day.
Exactly. Now ours are already stamped, but you know, if you got one from the factory, they may not be stamped. You want to mark them just for indexing them when you put them back together. Just another safety practice that we always like to use.
Right there.
Awesome.
Good.
So they're stamped. Now what we'll do is just, I got these loose already. We're going to take this rod cap off, and when we take this rod cap off, you may have some studs protruding there. You can take a little rubber hose and put it on there so you don't gouge up the cylinders or anything like that, but ours doesn't. Ours is just the bolts back down to the actual connecting rods there.
Reach it okay.
Yeah, that's perfect, man.
There you go.
I think you've done this before.
Yeah, well, time or two.
We'll keep that one obviously matched with this. I like to use a little hammer here, a little blunt tool, and just now that that ridge is gone, this guy should come right out at you. Here we go. Ready?
Yep.
1, 2, 3, catch.
Perfect. Got it.
Look at that.
You didn't even knock the bearing out. I'm impressed.
Yeah, that's cool.
All right, there's a good look at the guts right there. Now here's something really interesting. Let's come over here and look. We talked about evidence and kind of our own forensics all along the way in this project. Here you go, folks. There's the top of a piston right there where something, probably an electrode off of a spark plug, got loose, rattled, and banged in there. Look on the head. There's the mirroring action. Here's what it would look like. Imagine that piston doing its work with a little piece of steel floating around in there. Damage, damage. So we'll get all that buttoned up, get this thing taken care of, and get it back on the road.
Same thing with the main caps, man. They're all in order. They're all specified. They're in the right direction.
Really important.
So I'm going to take number 3 off. It says number 3 is stamped. If not, go ahead and stamp it.
There you go.
Pretty cool here. You can actually see the thrust bearing. We'll talk about that when we put it back together, but that keeps the crank from going back and forth. That's pretty cool.
See if you ate your Wheaties.
Got that out. Let's go a little. Come out of there.
Yeah.
That's a
He
big
makes it
deal.
look easy. I'll never hear the end of that.
Man, that's something. All right.
Go. Got our Rock Auto engine stand. Come back around.
Nice. All right.
Time to hone.
Man, we're in good shape, but before we measure, we want to put a crosshatch pattern in these cylinders so we can go ahead and hone them. Pretty simple. We're going to do a little crosshatch with this one. This is just like a little, basically a glaze breaker. We're not going in there and making it any bigger, but what you want to do is put it in there, and then you can go ahead and run it up and down, up and down. And you'll see the difference when I pull it out. So I'm going to run it. Little PB blaster in there to get it lubed up and nice and going.
Nice.
And then once I get done with that, stop it. Don't pull it out because your beads will fly. And when I wipe this down, you should see a pretty noticeable difference right here. And that looks nice.
Almost eat a meal off of that.
Now here's where that inspection comes in, Brian. I mean, now we can go, now we're gonna get a clean block, we're gonna clean it up. We're gonna make sure before we go too far, and we can go in and make a bunch of measurements. There's a ton of measurements.
Absolutely, and the hot soap and water is gonna get us where we need to be. Wife's a little angry, I stole her bucket, but that's okay. We're gonna get this thing nice and clean.
Absolutely, hot soapy water, that's the key. Well, stick around, Garage Ed's coming up, and we're talking to one of the biggest players when it comes to the input. That's the oxygen sensor. Plenty more Tech Garage, brought to you by rockauto.com.
Tech Garage, presented by rockauto.com, is brought to you by Hunter Engineering, state-of-the-art wheel aligners and wheel alignment machines. Steel Rubber Products, quality crafted rubber parts and weather stripping. And by rockauto.com, all the parts your car will ever need.
Well, welcome back to one of our favorite segments of the show, Garage Ed, here on Tech Garage, brought to you by rockauto.com. You know, my grandfather used to tell me pretty regularly, use the right tool for the job, kid. And I'll tell you what, when you're taking out an O2 sensor, that is critical, so you don't do any damage up here. I'm going to start getting one removed for a visual inspection. John's going to show you the massive critical work that this important sensor does.
Boy, and it's massive. It's one of the heaviest hitters on the car, the oxygen sensor. It's located in the exhaust stream, and what it's doing, it's reading the condition. Remember, command corrects condition. So it's reading the condition of what's going on. And take a look at this graphic. I can tell you how it works. You know, the outside oxygen has 21% oxygen in the atmosphere, and if inside the exhaust pipe, let's just say, for example, there was 18% oxygen. Well, there's not a big difference. So if there's not a big difference, that's a lean condition. Now, on the one on the bottom, you see that there's 21% oxygen in the outside atmosphere. On this one, you only have about 10% oxygen in the exhaust stream. Well, that's a rich condition. So command corrects condition. So what's going on? Well, check it out. I got it actually running right here on the board. This is live data coming from the oxygen sensor. And you can see it over at the screen. You have oxygen sensor number 1. It's switching back and forth, rich, lean, rich, lean. It's going all the way up to about 900 millivolts, and then it's dropping down to about 100 millivolts. And the quicker it does that, the better your car runs. We're trying to achieve that 14.7 stoichiometric number. So you can see rich, lean, rich, lean, rich, lean. Well, what's going on with that post-oxygen sensor? Well, if it's working correctly, it's behind the catalytic converter, and you can see it's really nice and steady. It's just going right along there. That means the catalytic converter is doing its job. If that second one was bouncing up and down like the first one, well, you got a deteriorated catalytic converter. Now, oxygen sensors, there's locations for them as well. You got post-oxygen sensors and pre-oxygen sensors. You can look at the second graphic right there, and you can see bank 1. You got bank 1, sensor 1, and then behind the cat, bank 1, sensor 2. On the other side is bank 2, and the other one is the second sensor down there. Now, those tests are great, but there's some cool visual inspections you can do. So let's check in with Brian.
Well, all we're really doing down here is a visual inspection of the O2 sensor. So with the tool, you get it kind of ready to come out by hand. Sometimes it's easier to take the wiring harness, push it up top if you've got room, and this will rotate out just a little bit easier. And voila, there's the O2 sensor. Now, you're inspecting a lot of things. First, let's look at the O2 sensor itself. Signature on this one is dark brown with some black spots. It implies that there's some oil getting onto the O2 sensor. Introduce a conversation now about catalytic converter life if oil's getting in there as a contaminant. If it was white and brown, possibly a little bit of green on this O2 sensor tip, that would imply antifreeze is getting down there. Again, another contaminant, and this guy's not going to perform properly. That can be a blown head gasket, even in its early stages, or some other type of coolant leak. And if it's bright white, almost like it's been dipped in a snowbank, that's almost always some type of RTV that's been used that's not O2 sensor safe. That could have been a valve cover job, or water pump, or thermostat, who knows? But you've got to use the right RTV that's O2 sensor safe on today's vehicles. So this is kind of an interesting one. I'm going to pull the other one, get a good look at as well. These guys have a really important job. You heard all about that. So we want to make sure that we're getting maximum performance so they can do their job really well. Well, for more cool tips, John and Tom have the rest of the story.
Tom, we talked about oxygen sensors, and those things are dealing in millivolts, man. That's a small voltage. I saw some butcher jobs with crimp connectors, this, that. Oh, man, it doesn't have to be that way.
No, it's a part that's a sentinel watching over a whole bunch of different systems. So you want to get the correct part. You don't want a universal one-size-fits-all sort of thing. And with rockauto.com, you can get the correct sensor, the correct upstream sensor, downstream sensor, and the prices will still be less than the conventional stores trying to sell you a universal part.
Now that's huge. Let's see what you got on the rockauto.com here.
Yeah, here's an example, a 2001 Toyota 4Runner. We've got upstream, downstream, a choice of manufacturers. You've got the OE sensor. You've got economy models that are still made for that specific vehicle, specific engine.
Now, Tom, a lot of our viewers may not know, but we talk about upstream and downstream all the time. Those connectors' lengths, those connectors themselves could be different.
Right. Yeah. Sometimes the connector itself, will, if it gets contaminated with oil or something, that can affect the oxygen sensor's performance.
Well, check it out online. Make sure you get the oxygen sensor that fits your car. You got a whole choice of them, so pick the one that you need. Matter of fact, we're going to head over and finish up today's show.
Well, there you go. That's rolling a little more freely than the top of the show. I'll tell you what, we got to verify the repair with a test drive, but you can already see the new caliper, new pads, resurfaced rotor. This thing's rolling down the road nicely. John, we have had a fun time today.
Yeah, thanks for saving my teeth from chattering. We did. We looked at the LS motor. We punched out the pistons. Now we know the condition of the block.
that.
And Garage Ed, we talked about one of the biggest players when it comes to actual balance. That's the oxygen sensor.
It's everything, and every week we're getting deeper and deeper into technology here on Tech Garage, presented to you by rockauto.com. Hey, come see us on Facebook, YouTube, and Twitter, and we'll see you guys next week.
Production assistance for Tech Garage is provided by Chapala College, located in Marianna, Florida. Founded in 1947, Chapala was ranked recently as one of the top 3 community colleges in the United States.